Okay, so this is the Hegarty 353 probability of an event not happening. So we're going to look through a range of these. I've picked out kind of four, starting from the most easy, and then they get a bit more complex as we work through them, but they all kind of follow one. So the first one, a bag contains 11 milk and 7 dark chocolates. A sweet is selected at random. What is the probability of choosing? And this notation just means probability of choosing a milk, probability of choosing not milk. Now the first thing we need to know is how many chocolates there are in total. So we've got 11 milk and we've got 7 dark, so we know 11 plus 7 is 18. So both these probabilities are going to be out of 18. Now the probability of choosing a milk, out of 18, we have 11 milk. So the probability will be 11 over 18. The probability of choosing not milk will be 7, because we have 7 dark chocolates. 7 over 18 is the probability of choosing not milk. So the important thing to take from that is we want to know how many in total. 11 plus 7 is 18, and that's going to be our denominator on the bottom of the fraction. And then on the top is just going to be whatever fits into the probability bracket. So probability of milk, 11 milks. Probability of not milk, well, the not milks, there's 7 dark chocolates. Okay, let's look at number 2. When you flip a biased coin, the probability of getting a tail is 0.31. Find the probability of getting a head. Now, the key bit here that they're trying to throw you off with, it's a biased coin, okay? If you flip a normal coin, then the probability is always going to be 50-50. Yeah, because there's an even chance. This is a biased coin, so they're saying that the probability of getting a tail is 0.31. So we got to find the probability of getting a head. Now, if you notice with 50-50, we're always talking in terms of 100 or in terms of 1, okay? Probabilities always add to 1. So the probability, if this was a fair coin, would be 0.5 to get a tail and 0.5 to get heads. So we're always talking for our probabilities to add to 1. Here, tail is 0.31. So if we start with 1, and we basically want to find what you have to add to 0.31 to get to 1. Well, we can work that out by doing 1 minus 0.31, which is 0.69. Okay, so the probability of getting a head is 0.69. Let's double check they add to 1. 0.69 for heads, 0.31 for tails. They add to 1, so our probability of getting ahead is 0.69. Let's look at question 3, and this is where they start to get a bit more difficult. The probability that Richard wins in a raffle is given by the expression P. Okay, so the probability that he wins is given by P. Write down an expression for the probability that Richard does not win. Now the key here is, we just said that probabilities in decimal form always add to 1. Okay, 0.31 plus 0.69 was 1. Now here we're given a letter, not a number. The probability that Richard wins in a raffle is given by P. So we know it needs to add to 1, and therefore the probability of him not winning will be 1 minus P. Okay, because P is representing him winning, and the rest of 1 is representing him not winning. So 1 minus P represents probability that he does not win. So it's basically 1 minus the probability of winning leaves us with the rest, which is our not win. Question 4. The probability that Rebecca wins a raffle is given by the expression T over U. Now this is where they start to get really complex. You'll probably have about 3 of these complex problems in the Hegarty task. You've just got to think about the basics that we've covered in question 1, 2 and 3, and then kind of apply them. So the probability that she wins is given by this expression, okay, T over U. Now, we're asked to write down an expression in the form of a combined single fraction, that just means as a fraction, for the probability that Rebecca does not win. Okay, now what we need to think about first is what this fraction represents. The probability that she wins is T over U. If we think back to our milk and dark chocolates question, the denominator was a total number, okay, the total number that it was out of. So U here is representing the total number. That means that T is representing the chance that she wins. Just like the numerator here was representing the amount of milks, T is representing the amount of chance that she has to win. So I'll just put chance to win. Now we have to combine what we learnt in question 3. If we're talking about a probability that she does not win, again, it's going to be out of the total number. So we want our denominator to still be U, because it's always going to be out of the total number. Now on 3, we knew that our total number was 1 and we were taking away P, and whatever was left was P not winning. So here we have U is our total number. U is almost representing 1, and we're going to take away T, and that top line there will be representing the probability that she does not win. Okay, it's the total minus the chance of winning gives us the probability of her not winning, and it's over U because that's the total chance. So on the top we've got the probability of not winning over the total. Okay, if you have any more questions, just give me an email.